So now let's finish up by reviewing solubility products. So first, a reminder, what is a solubility product? The idea is it's specifically an equilibrium for solids dissolving in water. So for example, let's take something like, I do AgCl down there. I don't want to take the same thing I'm already doing. So let's say we were working with, I should be able to think of more, lead chloride. Lead 2 chloride, it's a solid, and it's going to be at equilibrium with Pb2 plus aqueous plus 2 Cl minus aqueous. So a KSP for that would be just the concentration of the lead times the concentration of the chlorine squared, since there are 2 chlorine molecules, and you wouldn't have anything in the denominator since our reactant is a solid in this case. And this is true for all of our KSPs. KSPs are about the solubility of a solid compound turning into its ionic form, so the reactant is always a single solid turning into 2 or more ions, usually 2, or in this case, like 2 different ions, but you're made 3 total since every molecule turns into 2 chlorines and 1 lead. So you'll usually have 2 things on the product side. Some of them could be squared or cubed or something if you've got multiples though. So make sure to pay attention to that. So then there's some information we can do with this. So we've got big tables of these things that'll tell us how soluble are different compounds. In addition, sometimes you might not see it in the table, but you can do an experiment where you measure how much dissolves, and then you can figure out what you would get for a KSP value you could then use in other situations. So let's start with the first question about how much can actually dissolve. So if I want to know how much silver chloride can dissolve in pure water, I can use the KSP to figure that out. So we'll start with our chemical reaction. AgCl is a solid, and it's going to turn in to Ag plus aqueous plus Cl minus aqueous. So this is like 1211. What ions are things related to? Silver chloride, chlorine has to be -1, so silver's got to be +1. So we think of it like an ice table. We don't have to worry about any of the solids. They don't show up in the equilibrium. And initially, this solution has 0 silver and 0 chlorine. That won't always be true, but the problem said pure water. They let us know that there's nothing at the start. Then, since we're going to be dissolving it, we're going to be gaining more ions. So these have got to go up. We're going to get plus X and plus X. And then at 0 plus X, these are just X and X. So we know our KSP is equal to product over reactant, which in this case will be Ag plus times Cl minus, which is going to be X times X, which is X squared. That's equal to the KSP value we were given, 1.77 times 10 to the negative 10th. We then take the square root of both sides, and we'll get X, it's 1.33 times 10 to the negative 5th. And X in this case is going to be what molarity of your starting molecule can actually dissolve. Because as a reminder, this is an ice table, and for ice tables, you're always working with molarity. Oh, I forgot to put the labels. I, C, E. Because it was BAAs where we worked in moles. For our ice tables, we worked in molarities. So X, in this case, is going to be what's the molarity of AgCl that can dissolve. And 1.33 times 10 to the negative 5th molar can dissolve. Note that depending on what textbook you're using, I work with a textbook currently where they use S for this instead of X. It means the same idea. They're just trying to specifically say, oh, and this is the solubility case. They use the letter S to represent it. It's not meant to be anything different, though. In the future, I might not be using that textbook. This is just in case that's something that's coming up for those of you watching this. Now, let's look at the second question next. The question is, what is the KSP for a solution of silver chromate if you can dissolve this 10.9 milligrams in 500 milliliters of water? So first, for this problem, we've got to be able to work with molarities to be able to actually do anything. So we've got a lot of conversions to do at the start. So we have 10.9 milligrams. We know that there are 1,000 milligrams in 1 gram. We can also find the molar mass, and you'll find that for every 331.73 grams of silver chromate, you're going to get 1 mole of silver chromate. So this will give you a total of 3.29 times 10 to the negative 5th moles. So now I'm going to look at my balanced chemical equation for this. Ag2CrO4, silver chromate, is in equilibrium with 2 silver ions plus 1 chromate, which will be 2 minus to make the charges balance. What's important about this, you'll notice it's not a 1-to-1 relationship. That means for the silver, we have 6.57 times 10 to the negative 5th moles. For the chromate, on the other hand, we have 3.29 times 10 to the negative 5th moles. But both of these are in the same solution. They're in half a liter of water. So if we want to know the molarity is moles per liter. So we can divide both of these by our 0.5 liters to get our molarities. So our concentration of Ag plus, when we do 6.57 times 10 to the negative fifth divided by 0.5, get 1.31 times 10 to the negative fourth molar. And my chromate solution, on the other hand, is going to have that's supposed to be a 2, not a 7. I'm trying to make a 2 minus. I said it out loud, so hopefully you can see that's what that's supposed to be. And that's going to be 6.58 times 10 to the negative fifth molar. So then if I want to do the KSP, it's products over reactants, but the reactants are a solid, so they're just going to show up as a 1, so we just have stuff in the numerator. We've got Ag plus for silver. It's squared because there are 2 of them, and then chromate. And there's only one of those, so there's no square or anything. We put our numbers in. We'll have 1.31 times 10 to the negative fourth. We square that. We multiply it by our chromate concentration of 6.58 times 10 to the negative fifth. We put those values in. We'll get a KSP of 1.13 times 10 to the negative 12. And that's our value for our KSP, based on the fact that 10.9 milligrams of silver chromate could dissolve in 500 milliliters of water.